Looking at balancing of chemical equation. Meanwhile, the balancing of chemical equation requires a step-by-step process so that you can balance the number of atoms of element on the product side and the one on the reactant side. Now, meanwhile, these are the questions that we'll be looking at. As we look at these questions, we want to see how to balance the equations of all these unbalanced. Some of them might be balanced, we don't know. But for an equation to be balanced, the number of atoms on the product side and the one on the reactant side must be the same or equal. Now, let's say we have the first guy there is xenon. Xenon is reacting with iron. So when xenon reacts with iron, you get this xenon fluoride. Oh, sorry, fluorine. Xenon and fluorine, not iron. Okay? Because iron is Fe. You get the point now? So xenon and fluorine, you get this xenon fluoride. Alright. Now, the first thing to do is to list the number of elements on the product side, on the reactant side, and number of elements on the product side. If you look very well, you will see that xenon is just one, and then fluorine is two of those. And if you look at the product side, xenon is still one, but fluorine over there is 6. Alright? So what is wrong with this equation? Xenon is good to go. But fluorine, we have 2, we have 6. Common sense. We're going to use common sense for this. So the common sense you're going to do, you're not supposed to change the subscript. This thing is called subscript. You are to change the coefficient. If you do a little bit of mathematics, you understand that coefficient is a whole number in front of an unknown value. Are you following now? If I say 2x, the coefficient is what? 2. Are you following the whole number there? So what you are changing is the coefficient and not the subscript. Now the subscript is this guy in front of the fluorine. Now look at this guy over here. This is 2. What will I do to 2? What will I multiply by 2 that will give me 6 to balance this? It is 3. So 3 times 2 is what? 6. So this guy will be 3. You see now, 2 times 6, or 2 times 3, or 3 times 2, 6. Not 3, 6. Then, yes now, 3 times 2, 6. This one, 6. 1, 1. This equation is balanced. So we'll go to another one. Another equation now. Should I clean up here now? So that I can have big space? Yes. Alright, let me clean up. Alright, we'll pick the next equation. We have silver. We have Professor Silver reacting with hydrogen sulfide. And when silver reacted with hydrogen sulfide, the sulfide reacted or combined with the silver to form silver sulfide. And then we have hydrogen. That means hydrogen was displaced. Alright? Now, meanwhile, let's count the number of atoms of elements. Silver is 1. Silver over there is 2. Hydrogen, remember now, is 2. Hydrogen over there is what? 2. Sulfur is what? 1. Sulfur over there is what? 1. So is the equation balanced?
No.
Yes. No, it's not balanced. So sulfur, good. Silver, hydrogen is balanced. But the silver has a problem. Common sense. If you put 2 here now, 2 times 1. So this is 2. So that this equation will be balanced. It's very easy. You see that now? Very, very easy. Just look at the equation. List the number of atoms of elements and then look for the one that is having a problem and work on it. Are you following now? So let's go another one. Let's take that equation. Potassium hydroxide. Potassium hydroxide is reacting with carbon 4 oxide. So when potassium hydroxide reacts with carbon 4 oxide, it's going to give me potassium triosocarbonate. You can go and solve. That should be triosocarbonate 6. Okay? No. Let's solve it. Let's solve that. Let's say we have that guy K2SO3. Potassium is 2. Carbonate what? We don't know that. Plus oxygen minus 2 times 3. Everything is equal to 0. There's no charge. So this is 2 plus x plus 2 minus 2 times 3 is minus 6. Everything is equal to 0. So we have x. Move 6 to the other side. Plus 6. Move 2 to the other side. So X is equals to 4. So that is potassium triazocarbonate 4. So let's write it there. Potassium triazocarbonate 4 plus water, H2O. Let's list out the number of atoms of elements on the reactant side and on the product side. On the reactant side, we have 1 potassium. Oxygen is 1 plus 2. 1 here, 2 here. 1 plus 2 is what? 3. 1 plus 2 is 3. Carbon is what? Carbon is 1. The subscript affects only oxygen. Yes. It doesn't affect the carbon. Are you following now? Yes. So potassium over there is how many? 2. Carbon is 1. Oxygen is 3 plus 1. 3 plus 1, 4. So we have hydrogen. Where do I get hydrogen from? Okay, hydrogen is here. Hydrogen here is what? 1. Hydrogen here is what? 2. Now let's check which one is balanced. It seems like all of them is out of place. Okay? So that's good. Then what we do, let's start with potassium. Potassium is 2 there. If I add 2 here, 2 times 1? 2. So this one will become 2. This one is already 2. Are you with me? But this whole number is going to affect everything inside this place. So we're going to have 2 times 1, 2. So oxygen will now become 2 here plus 2 here, which is equals to what? 4. 2 times 1 is 2. Yes. 2 from here is equals to what? 4. Hydrogen will come. 2 times 1 is what? 2. So hydrogen will change to 2 to balance out this one. Are you still there? Yes. So the carbon now, carbon is 1. Carbon is 1 here, carbon is 1 here. Over here, carbon is 1, not 3, please. You have one that made it to it. Carbon is 1 here, and carbon is what? 1 here. So let's check our atoms of element. Potassium 2, potassium 2, good to go. Carbon 2. Oxygen. Oxygen, yes. See, oxygen is having a problem. Oxygen is 3. 3 plus 1? 4. So oxygen is 4. It's 4. Oxygen here, okay, is also 4. So oxygen is good. Oxygen is good. Carbon 1, carbon 1, good. Hydrogen 2, hydrogen 2. So the equation is balanced. So what we are doing is that the number of atoms of elements on the reactant side and the one on the product side must be equal. Alright. Shall I clean up the board now? Let me clean up the one at the top over here. Alright, and leave this one down. So now we have this guy there. What's his name? Sodium. Professor Sodium is going to react with Dr. Chlorine. So when the two of them react, remember I have a positive and a negative. Negative ions is going to cancel out. This will cancel out this. And then we have sodium chloride. The equation is already balanced, so we don't need to do anything there. 1 sodium, 1 sodium, 1 chlorine, 1 chlorine. So the equation is balanced. So let's do another one. We have this guy. You need to pay attention. Okay, water. Hydrogen plus oxygen will give you H2O. Now, if you are balancing a chemical equation, what you are going to change is the whole number and not the subscript. Okay? Is it 2H2 or just 1 H2? It's 2. It's 2. Okay. Now this is 2. This is 2. This one is 2. This one is what? 1. Let's list out what we have so that we don't make mistake. This one is hydrogen is 2. Oxygen is what? 2. Hydrogen is 2. Oxygen is 1. So we have a problem with oxygen. So what we're going to do, if you put 2 here, if you put half of 2 is what? 1. Half of 2 is 1. So if I put 1 half here, half times 2 is 1. So it will make oxygen 1. But this thing is not allowed. We don't use fraction to balance a chemical equation. Are you following now? Now, because we don't use fraction to balance a chemical equation, what do you think we should do to this compound? Think first. I'll show you 2 methods of solving it. I'll use the first one. The first one is clean up these 2. Alright? Clean up these 2. Now, if you put 2 here, 2 times 2, 4. Hydrogen will become 4. If I put 2 here, 2 times 2, hydrogen will become 4. Oxygen is 2 times 1, 2. Oxygen is now 2. Oxygen is also 2. That is the first method. I'll show you another method to solve it with. Alright? I'm cleaning this one. Should I clean this one now? Alright. So if we use this method, Let's see whether it will work anyhow. So we have hydrogen. Let me write the equation now. Hydrogen plus oxygen giving me water. All right. Yes. So now the problem I have here is that water and oxygen. Sorry, so I put 1/2. Now if I multiply out by 2, what will happen? 2 times 1
is 2.
So 2H2 plus 2 times half. Half of 2 is 1. Half of 2 is 1.
1. So
we have just oxygen. Alright? Now 2 times this guy
is 2.
2H2O. So you see what we have here, we have here. So any method that is more convenient for you, you use. In case you cannot be able to think of what number to put here, what number to put here. Are you following what I'm saying now?
Yes.
Just multiply the whole thing by 2. We are going to remove the half. Are you following? Let's do it again. It will happen here now. What I just said now will record here. So let's write it up here.
Yes.
You will see it will reoccur. Let's just solve. You will see what I mean. We have carbon, 4 hydrogen. This is called butane. Butane reacts with oxygen to give me carbon dioxide and water. The first thing to do is to list out the number of atoms of elements. Carbon is 4, hydrogen is 10, oxygen is 2. Carbon is how many there?
1.
Carbon is 1. Hydrogen is how many there? 2. Oxygen is how many there? 2. Alright. Now the first
3.
Oh, 3.
Yes,
Okay, so 3. Over here, carbon is 4. Carbon is 1. Any question? Carbon is 4. Carbon is 1.
No battery, please charge.
Don't worry, let's continue. So now, what we have over there, let's hurry up so that we'll map up with the space of the time we have on that camera. Alright?
Yes.
Okay. Now, over here, see what will happen. This guy is already 1. If you add 4 here, it will cancel out this. This will become 4. It balances the carbon atom. But there is a problem with oxygen. 4 times 2.
6.
4 times 2 is 8. 8 plus 1.
8 plus 1 is 9.
9. Calm down. If I put 5 here, this is 10 hydrogen. If I put 5 here, 5 times 2 is 10. So this one is 10. Hydrogen is also 10. It's balanced. But there's still a problem with oxygen. 4 times 2 now is 8. So 5 times 1.
5.
So 8 plus 5. I'm having a total of how many oxygen? I think it's 13. Alright. So what we have here will become 13 over 2. 13 over 2 inside of the oxygen. Let me tell you what I mean by that. Carbon is 4. Here. Carbon is what? 4. Here. Good to go. Hydrogen is 10. Here. Hydrogen is what? 10. Here. 5 times 2. Good to go. Oxygen is 2 here. No problem. Just don't worry. 4 times 2, 8. 5 times 1, 5 times 1, 5. 8 plus 5, 13. Oxygen is 1. So oxygen have a problem. So if I put 13 divided by 2. Are you following now?
Yes.
Why I'm putting 13 divided by 2? Look up. Why I'm putting 13 divided by 2 is that we need what we are going to multiply out with 2 to get 13 oxygen.
Yes.
Don't divide. Just, you can leave this answer like this, but it's not good. We need to balance it out so that it will be on a whole number. We don't need a fraction. Okay? If I multiply by 2, watch the miracle that will happen now. Look at the miracle. If you multiply by 2, a miracle will happen. 2 times this guy. It will become 2C4H10 plus, if 2 multiply this, what do you think will happen? Multiply. If 2 multiply, this is 13 over 2 times by 2 over 1, okay?
Yes.
This times this. 13 times 2.
26.
26. Divide by 2.
Yes.
Divide by 1 will give me
13.
They will give me 13. So that I will have 13 oxygen. Good. 13 oxygen. You see that now? Yeah. Alright. But we still have a lot of things to do. Alright, we have over here 4CO. We are multiplied by 2, sorry. 2 times this guy. 8 carbon dioxide. 2 times this guy. 2 times.
10.
That is 10. 10H2O. Let's recheck our equation again. Or let's use this like okay. Alright, let's check. 2 times 4.
8.
2 times 4 is 8. So this one will change to 8. Carbon is 8. Come over to this place. 8 times 1.
8 times 1, 8.
8. So carbon will also change to what?
8.
8. Are you seeing the way it's going now?
Yes.
Alright. Let's go to hydrogen. Hydrogen is here now. 2 times 10. 20.
Yes.
Abi?
Yes.
So over there, 10 times 2.
20.
20. So hydrogen will change to 20. Hydrogen here will change to 20. Apoko. So now oxygen is 8 times 2.
16.
16 plus 10. What will it give you? 26. Abi?
Yes.
Alright, 13 times 2 children.
13 times 2
It's
is
26. So you see now, 26 here, and then 26 here. So that's how to balance that equation. Very, you have to multiply it. It's not when you multiply out, you will do your answer. So this last one, I'll leave it for you to solve this acid-base reaction. When you solve it, you drop the answer on the comment section. We'll see you right in the next class. Bye for now.